At the control panel, set the service rocker switch to the service mode. This will provide yellow with red out to the corner arm to allow us to do the floppy wheel. At the swing tower box, turn the disconnect off and then remove the 3/4 amp fuse out of the guidance receiver box. This will disable the steering function of the corner arm. In the swing span box, we will install a jumper from 10 to 12 on the 5 relay printed circuit board. This will bypass the guidance receiver and the reference antenna safeties.
The next step in this process, we turn the wheels towards the swivel of this corner arm. We'll want these tires as parallel and straight with the corner arm span as possible. And one way to do it is looking down at this pedestal. We can compare the tire to the base beam and shoot for 90 degrees off the base beam. And at this point, I think we're fairly close.
At the operator interface panel, we will use the rocker switches under the swing tower command. We will use the steer in, steer out, and the jog forward, jog reverse buttons to control the steering. We're looking at the steering, control the steering leg on the outboard drive motor. You will want to steer it in, steer it out, jog it forward, jog it back until you can get a floppy wheel, basically equal distance, all the way around the inner drive unit leg to the outer drive unit leg of the outboard drive unit. Now we will turn off the operator interface panel disconnect, or sometimes known as the SDU panel. We'll turn the disconnect off, and now we will unwire the outboard drive motor lead so that the outboard drive motor will no longer be able to move. We will now wire nut the wires or move them into a safe location, turn the disconnect back on, and now we will gently jog the inboard drive motor, jog it a little bit forward, a little bit back. Do not do any steering or else you will change the floppy wheel on the outboard. Only jog forward and reverse. Get it to the truest floppy that you can on the inboard, and at that point we will call it good. Once the floppy wheel has been attained, you're at the point now that you can calibrate and set the span sensor potentiometer. Please refer to your Model 8000 Precision Corner Manual for the proper calibration.
The next step in this process, because this corner is newly built, the span sensor has never been adjusted. So at this point we've set the pedestals, we have the floppy leg, everything's happy there. We're going to now go into the smart board into the display group, which is the first group. Hold the blue button down until it says display. We hit blue again. It gives us our span sensor voltage. So I hit white, and as you can see it says 3.33, 3.32. So now what we're going to have to do, we're going to walk out on the span and we're going to adjust the pod out there that senses the compression and tension within the span, and we'll have to adjust that now for 2.84 volts. What that means is the computer is always reading and looking for 2.84 volts. When this span goes into tension or compression, it's going to change the voltage with that pot, and in so doing going to tell this variable speed drive on the corner arm to either speed up or slow down to catch up with the LRDU. So we definitely have some adjustment to make at this time, and we'll proceed out onto the span and adjust the span sensor. Okay, now that we're out here on the span, we took the lid off. We've got our pot here. Normally this screw is going to be up here at this factory setting closer to the black line. As we looked at earlier, the display showed 3.32 volts, which is too high. So we're going to find as we adjust this screw will probably come down closer to the black line here on this galvanized piece. Also, I've got a meter here, so as we adjust this, I can put my meter on the black and blue wire coming off this pot, and right now we're showing 3.66 volts. I can adjust the rod, and that will bring that number up and down accordingly. And that's the wires coming from the pot. We have to remember, if you're out here by yourself, my body weight on this span will make a difference, like 0.3 of a volt. So we'll have to adjust things accordingly, because when I walk off this span and get back to the display panel, the number will vary. After doing a bunch of these, I know that normally if I set the digital display here, my meter reads about 3 volts. I can walk back to the display box and it'll read about 2.84. So right now, again, we are reading about 3.6. So I am going to adjust this rod and change that number. It will take some trial and error. 3.19, so we're getting closer. They've got jam nuts on both sides of this plate, so when we do get it fine-tuned, we can lock it in place. Check it again here. 3.18, I need to let the rod up a little bit more. 2.98. Now that's getting very close to where I want to be with the weight of my body. We'll probably lock that in, and we'll go back down to the SDU panel and check in the display to make sure that we're now reading 2.84. As you can see here, this screw is lined up a lot closer to the black mark on that galvanized plate, so we know we're getting closer to where we want to be. Okay, we're going to be just a hair under.
Okay.
Agree with that?
I'm okay with that. 2.83?
No, 2.83, 2.82. And it gets closer as it comes down. So the point is, I'm going to go back up there. When he gets that reading, say it's 3.01, I'm going to actually adjust it to 3.03.
Okay.
And we need to gain 0.02 of a volt. And then when I come back, because now I know we're off by a couple hundredths.
Yeah. We're shooting for 8.4, right?
Right, so I need to go up, we need to gain 200.
Yep.
Go you and me.